Hi everyone, in today's video, my idea is to teach you how to use Stata for factor analysis. As the last time, I'm going to begin with the explanation of some aspects about this method. So let's start with a brief presentation about factor analysis. First, you must keep in mind that factor analysis, just as the PCA method, works with variables that are related. Remember that those variables have to be correlated, and it doesn't matter if it is a positive or a negative correlation. Also, this method of grouping, the output is an idea or a concept that not can be inferred so easily from the data or observations, but that idea represents a relationship between the variables that you are going to use in the factor analysis. Also, the idea is that the factors that will result from this method lets you to have a more easy interpretation of the variables and from the original data. Now, in order to compare both methodologies, first, for example, in the principal component analysis, remember that the components that the Stata generates seeks to explain the total variance from the data. Otherwise, the factor analysis seeks to explain the common variables of the information. Also, in the principal component analysis, always the first component of component number one is going to be the one that explains the most part of the total variance. And in the factor analysis, we assume that there is a common factor that that lets you relate all variables. Finally, in terms of correlations, it is a significant difference between both methods, because always in PCA we get a correlation between the components equal to 0. Nevertheless, in factor analysis, the correlation is not always going to be 0 between the factors that you are creating. However, it is a method in Stata when you can work factor analysis by using PCA, the principal component analysis, and in those times when you use factor analysis with a base of PCA, then the correlation will be 0. Later in the video, you are going to be able to see this. Also, as it was explained in class, in factor analysis, you can also rotate the factors in order to have a better interpretability of the factors. In this way, the new factors, the rotated factors, will be concentrated in certain variables. Therefore, you will gain interpretability of what kind of data each factor represents. And this also will lead to some changes between the correlations of the variables that you are generating. I mean the new factors. Also, some aspect that you must not forget is that when we want to review common characteristics that are present in all the variables that we are analyzing, then we use factor analysis. The variables that are not summarized in this methodology. They are explained through factors. And finally, the factor seeks to show you observable characteristics or relations between the variables that are not easily observable in the original data. And this is the end of the presentation. The Kaiser-Meyer-Olkin test, most commonly known as KMO, it is number that will let you decide if the data that you are analyzing is properly adjusted to use factor analysis or PCA methodology. Here in the screen, you are seeing like there are like categories according with the number of KMO that the data represents. So always that a data set has KMO higher than 0.7, then there is a strong correlation between the variables. So it will be useful to implement factor analysis or principal component analysis. Now I'm going to go to Stata. Good. So for today, we are going to use a new data set. So remember to import the file in Stata. The dataset, its format is Excel. So we're going to import an Excel file. And this is the new dataset that we're going to use today. Remember to, in this case, for example, the first row represents the names of the variables. So this option must be selected. Okay, so this new dataset contains information about the scores that Colombian students got in their ICFES. And also there are some social demographic information about them. For example, here you will find like with how many people they live in their home, if they have access to internet, if they have a car, but also there is the information, well, this is information about the school where they studied. And here at the end of the data set is the information about each discipline that this evaluation presents. So for example, here is the score from reading, a score from mathematics, a score from biology. So there are in total 5 categories from the evaluation, and also at the end you will find like the global score for the student. So those kind of variables are those which we are going to use today in this video. So first we can start with the factor analysis. This is by using the command factor. And after that, we are going to select the variables that we want to analyze through factor analysis. So for example, in this case, I'm going to choose this one, which represent like the level of life that the student has. And also if the student has internet connection at home. Also, I'm going to choose all the variables that represent the score from the different disciplines that this exam evaluates. So let's start here with reading, mathematics, biology. This is like social science, English, and finally the total score that the student got. So I think that in total we have 8 variables that we are going to analyze with factor analysis. And in this video, I would like to use the factor analysis, but that implements also the PCA method. So to do that, just use a factor command, and after you select all the variables that you're going to analyze, you will write a comma and a PCF. So this is like the result that Stata presents. Here, just as in the principal component analysis, Stata presents you the eigenvalues, the proportion of the variance of the data that each factor represents, and here is the loading plots of each factor. So the first step is to select only the factors that have eigenvalues higher than 1. In this case, you can see that there are only 2 factors that that has the eigenvalues higher than 1. But we here also we can create an script plot and to identify a line in 1. So with a graph, we will determine how many factors we are going to use. In this case, there are going to be the first 2 factors. After that, we can create a graph in order that will let us interpret which kind of information each factor represents. So for that, the command is loading plot, and after that, factors. And remember that we are only going to use the first 2 factors, so right here too. So here, what we can watch by analyzing this graph is that factor number 1 represents mostly the information related with the scores that the student got from their exam, while factor number 2 captures information about social demographic information of the student, that in this case is like the life level, and if the student got internet connection at home. So each factor is representing different types of information. And that graph is just the graphical representation from those loading factors. And finally, it's also important that you keep in mind that we choose 2 factors, and those 2 factors captures at least it's very near to 80% from the common variance of the information. So it is good because you are capturing the at least 80% of the information from 8 variables with only 2 factors. Also, okay, we can like create the factors as a variables. So to do that, we use predict, and after predict, we are going to select the names of the factors. So I'm just going to choose F1 for factor number 1 and F2 for the other one. And here Stata will create 2 new columns which represent the scores for factor 1 and factor 2 in this case. Also, we can, with these 2 new variables, we can calculate the correlation between them. Remember that because I'm using the factor analysis that is based in principal component factors, the correlation between those 2 variables must be 0, okay? So let's validate this, and as I told you, the correlation between factor number 1 and factor number 2 is 0 because I am using the principal component factor method. And also remember that we can like rotate the factors in order to improve the interpretability of each step. Nevertheless, I think that according with the loading plots, the interpretability is it's at good level here. I mean, by seeing those numbers, you can easily assume that this factor represents the variables related with the scores because it has higher numbers like for these variables. And in the case of factor number 2, the interpretability is concentrated in the variables related with the social demographic information about the student. But anyway, we can like rotate the factors. You have to only use the command rotate, and it's going to present new factor loadings in which we will see maybe higher loadings for factor number 1 in those variables and less loadings here in these 2 variables that are not as important, and this one in this case of this factor. And at the same time, in factor number 2 is like the contrary. For those 2 variables, you will have a higher loadings, while those loadings are lower. And to finish, we can to evaluate the KMO. So to do that, we use the command stat and KMO. So for these variables that we are analyzing here, we got a KMO equal to 0.4. So remember that in our like table of KMO, the KMO results in an unacceptable correlation between a variable. So it is not enough the correlation between the variables to implement factor analysis or PCA analysis. So you must keep in mind that component. Now to finish, I would like to show you a method by which you can create really interesting graphs with Stata. This is not going to be related with factor analysis, but I think that maybe it could be useful for your project. So for to do that, I'm going to use another data set. And I think that this data set is in a different format. So let's import from here. Yeah. This is the new data set that we are going to use. Stata automatically found how to delimiter the information from the data, and also gives already like the type of information that each variable contains. For example, those two variables have a string variable because it contains a text, while the other three variables are numeric. Good. So this data set represents information about the gross domestic product from different countries, and it gives like a differentiation between three principal industries, which are manufacturing, agriculture, and services for each country. So in order to create interesting graphs, the first step it's that I'm going to graph the agricultural, manufacturing, and services scores. So for that, remember that we use graph matrix because we are creating a graph with more than two variables. So we use graph matrix. After that, we choose the three variables, and always in terms of having a better graph, we are going to use this last part, half. So here you can see like how those variables could be related. For example, we can assume that countries with low, I don't know, investment in manufacturing activities maybe will have higher investment in agriculture, which is the case, for example, of this country. It has a higher investment in agriculture than in manufacturing, okay? That's how you interpret those graphs. Also, we can create a scatter, which is a graph with only two variables. And I'm going to graph manufacturing and agriculture, but only the information related with Colombia. So to do that, I mean, this graph will present the information from all the countries. But if I want to only graph the information about Colombia, what I could do is at the beginning is the same, and after that I'm going to create an if. So if this this variable is equal to this is the code of the variable. So in the case in Colombia, the code of the country. So in the case of Colombia, it would be col. And after that, Stata will only presents the like the point of the agricultural and manufacturing GDP for Colombia. Nevertheless, I think that it lost interpretability because you won't be able to compare with other countries. So maybe we could try to create a more difficult graph in which there will be all the countries, but you can but you will can differentiate easily the information about Colombia. In that way, we are going to implement a graph two-way. That's the code two-way. And the first graph will be an scatter of the two variables that we want to analyze. And in the second part will be another scatter of manufacturing and agriculture if the country code is equal to Col. So what we have like in this part, it's like a combination of graphs. So first we will have, this represents that it's a combination of graphs. After that, this means that you are going to create a graph with all the information about manufacturing and agriculture. And also this is to differentiate those points that that follows this this condition. So here you will see like the information of Colombia in terms of manufacturing and agriculture. Oh, I think that I put agriculture twice, sorry. Yeah, so here, all the blue points are the rest of the countries, while the red point is Colombia. Also, for example, you can like edit the way of the information from the graph. So also with a graph two-way, like it is a very similar graph. And this will be, for example, here, we are going to change the size of the points from the rest of the countries. To do that, we use M size and in parentheses, V small. So the points that represent the other countries will be shorter than the Colombia. And for Colombia, we can also like add a label to the point, so we can see more clear that point refers to Colombia with M label. And in parentheses, you are going to write like which information do you want that appears in the graph for that point. So I'm going to use the code. So here we have the same graph, but the rest of the countries are represented by points that are different from the one that represents Colombia. And also here is like the code of our country. So well, I think that's all for today. I hope you find this video useful, and good luck. Bye.